At 4:07 a.m. on November 28, 2019, a massive secondary explosion ripped through the darkness at the TPC Group facility in Port Neches, Texas. This detonation occurred 13 hours after the initial blast. Emergency responders were already positioned on site, attempting to suppress the chemical fires stemming from an earlier pipe rupture when the subsequent shockwave hit. The facility was heavily regulated. It operated under the strict requirements of the OSHA Process Safety Management Standard, a federal framework designed specifically to prevent these types of catastrophic events. Routine inspections were logged, and the required safety paperwork was filed with regulators. Yet the plant still detonated with enough explosive force to trigger a mandatory 4-mile evacuation zone for the surrounding community. Safety binders and compliance audits cannot override the physics of highly reactive chemicals when a facility's administrative controls fail on the plant floor. Before the incident, the Port Neches site was primarily dedicated to processing 1,3-butadiene. Butadiene is a highly flammable, highly reactive organic compound. The chemical industry extracts and refines it at high purities to serve as a key precursor in the manufacturing of synthetic rubber and plastics. Because of its reactive profile, butadiene is classified as a highly hazardous chemical. Facilities handling it in large quantities are required to comply with OSHA Regulation 29 CFR 1910.119, known as the Process Safety Management Standard. The PSM standard mandates a system of 14 interrelated elements. These include strict requirements for process hazard analysis, where operators proactively identify risks, and mechanical integrity. The core assumption across the chemical sector is that with a functioning PSM program, the hazardous chemicals within pipes are safely contained. To understand how this assumption failed at TPC, we will conduct a forensic audit of their PSM architecture. The collapse at TPC resulted from a fatal disconnect between the PSM paperwork and the physical reality of the plant's piping network. We can map the specific regulatory failures at Port Neches directly against the physical layout of the facility. A pervasive operational bias exists in chemical manufacturing, the assumption that taking a process pump offline for maintenance temporarily removes it from the immediate risk equation. TPC maintained a written procedure for managing dead legs, sections of piping where fluid becomes stagnant. However, their procedure contained a fatal omission. It failed to account for temporary dead legs created when primary equipment was taken out of service. Exactly 114 days before the explosion, plant operators took a primary process pump offline. This action created a dormant, blocked-in pipe section, initiating a microscopic chemical reaction inside. Facility management treated this offline pump as a production delay to be managed. They failed to recognize the escalating safety threat actively growing inside the dormant piping. An offline, stagnant pipe containing high-purity butadiene poses a severe hazard. Without continuous flow, the chemical is highly susceptible to auto-polymerization, transforming from a liquid into a rapidly expanding solid. The second critical failure centers on the facility's 2016 Process Hazard Analysis Review. 3 years prior to the explosion, the PHA team specifically identified the hazard of solid polymer accumulation. Their report mandated a clear action item: all out-of-service lines must be flushed on a monthly basis. TPC management formally accepted the safety recommendation. They assigned a completion date of December 2016. Over the next 3 years, the facility failed to implement this mandatory flushing protocol. Ignoring a formal hazard analysis recommendation is a direct violation of OSHA Standard 1910.119 paragraph E. It also represented the facility's final opportunity to intervene and prevent the 2019 disaster. The third failure involves ignored leading indicators. By July 2019, the South Unit was experiencing massive, visible polymer fouling that severely disrupted plant operations. This technical image shows the dense, white, cauliflower-like material known as popcorn polymer completely plugging the tubes of a heat exchanger bundle extracted from the process line in September 2019, just weeks before the explosion. Despite this physical proof of dangerous polymer growth, the over 114-day clock continued to tick. The dead leg created by the offline pump remained entirely unflushed. Deviance from safety protocols had become normalized. Management treated critical hazard analysis recommendations as optional suggestions, allowing a known chemical threat to grow unchecked inside their piping. This flowchart illustrates the reaction mechanism for 1,3-butadiene. Popcorn polymerization is not a slow scaling process like rust. As shown in the growth phase section, it is an exponential, space-consuming chain reaction where active polymer seeds continuously consume monomer to expand. Inside the 16-inch diameter dead leg at TPC, the solid polymer expanded exponentially. The material pressed against the steel walls until the internal strain exceeded the structural yield point of the pipe. At exactly 12:54 a.m., the physical limits of the steel were breached and the dead leg violently ruptured. Within 60 seconds, 6,000 gallons of highly pressurized liquid butadiene escaped from the ruptured pipe. As it hit the atmosphere, it instantly vaporized into a heavy cloud that expanded outward along the ground. 2 minutes after the release, the massive vapor cloud found an ignition source, initiating a catastrophic fire across the facility. The rupture was the predictable physical result of 1,3-butadiene reacting in an unflushed dead leg. The severity of the incident compounded due to the failure of mitigation engineering. Specifically, the plant lacked remotely operated emergency isolation valves on the butadiene process unit. While manual isolation valves existed, they were positioned deep inside the immediate blast and fire zone. Sending operators in to manually close them would have been a suicide mission. Without remote isolation capabilities, the ruptured pipe could not be sealed. The continuous flow of hazardous fluid fed the fire for weeks, directly precipitating the secondary explosion at 4:07 a.m. These cascading systemic failures exacted a severe physical toll on the surrounding residential community, destroying homes and triggering mass evacuations. For environmental health and process safety directors, the Port Neches incident provides a severe lesson. A process hazard analysis is merely a meaningless paper exercise if its specific action items are not strictly enforced on the facility floor. When administrative deviance becomes normalized, the physics of the hazardous chemicals involved will eventually execute a violent final audit of the facility's safety program. Subscribe to HSEstudy for more deep dives into industrial safety and systemic failure.